Okay, I love traveling. As I'm a student, I would like to buy cheap tickets. I believe that almost all of you would like to buy cheap tickets as well. I realized that my study is related to this ticket cost reduction. Modern airplanes consist of up to 50% of composite materials. And despite the recent advance of automated manufacturing process of composites, the inspection and the repairing process reduce the automated the manufacturing downtime up to 50%. And we would like to approach eddy current testing in order to fill this gap. As you can see, we are applying eddy current testing on our automated fiber placement, which is a common way of automated fiber production. By using these composite materials, by varying wrinkle height of each sample, we come up with this experimental setup where we are using handyscope to generate our signal to our current source, and the current source provides with consistent current supply to our driver coil, and the driver coil generates the magnetic field which receives by the pickup coil, and is transferred to handyscope again to compare this reference signal with received pickup signal. As you can see, you can see from right hand side figure the measurement results, how it looks like. From 0 to 200 probe positions, you can see the probe noise, which is very small, and the pickup signal. We have this clear pickup signal and the SNR calculated in order to assess it in quantitative manner. So you can see that the peak-to-peak signal divided by area mass of the structural noise, it's a way of SNR calculation. You can see these 4 probe configurations, A, B, C, and D, and in the second row it shows the optimum frequency selection study. It is highlighted by the Japanese authors Hiroyuki and Koshikagawa and their research team that the best probe configuration was found just beyond the resonance of the pickup coil. And you can see that in our research for probe configuration A, we found that the frequency, optimum frequency at 1.1 megahertz, and for other probe configurations B, C, and D, we have found it at 1.6 megahertz respectively. And in this third column of our measurement results, you can see our wrinkle height detection by using these 4 probe configurations, and both 2 top sensor configurations show relatively low SNR, and the rest of the probe configurations shows high SNR because the orthogonal position of driver coil relative to the pickup coil generates much more magnetic field, resulted in much more eddy current density. So as you can see, in conclusion, different asymmetric transmit and the differential receive exhibits excellent SNR for fiber features. The best probe configuration for 1.3 millimeter wrinkle height shows 20 SNR, and in the future we would like to embed our best probe configuration into the AFP head in order to inline monitor the automated fiber manufacturing process. Thank you for your attention.